It is permissible to route both 120-volt and 277-volt lighting circuits originating from different panels through the same low-voltage relay panel, provided certain conditions are met according to the National Electrical Code. NEC Section 300.3. The 3 allows for circuits of different voltages to occupy the same enclosure, as long as they are physically separated by a barrier. This provision addresses the safety concerns associated with having different voltage levels in close proximity and prevents accidental contact between them. The requirement for a barrier ensures that personnel working on the relay panel are protected from potential hazards. NEC Section 404.14. B stipulates that low-voltage lighting circuits must be installed in a raceway separate from other circuits. However, this regulation specifically excludes low-voltage relay panels, indicating that the general rule regarding separate raceways does not apply in this particular scenario. This exception recognizes the unique function and construction of low-voltage relay panels, which are designed to accommodate multiple circuits within a single enclosure. NEC Section 404.14. C mandates that circuits of different voltages must be clearly identified using distinct colors or other suitable means. This requirement is essential for ensuring that electricians and other qualified personnel can easily distinguish between the different voltage levels and avoid making potentially dangerous mistakes. Proper identification helps to prevent accidental connections or incorrect wiring, which could lead to equipment damage, personal injury, or even fire. Therefore, there is no code violation as long as the following requirements are met. Firstly, the 120-volt and 277-volt circuits must be separated by a physical barrier within the relay panel. This barrier serves to isolate the circuits from each other, minimizing the risk of accidental contact and preventing the spread of electrical faults. The barrier should be made of a non-conductive material and should be securely installed to provide adequate protection. Secondly, the circuits must be clearly identified using different colors or other effective methods. This identification system should be consistent throughout the installation and should be readily visible to anyone working on the relay panel. Color coding is a common method of identification, with different colors assigned to different voltage levels. Alternatively, other methods such as labeling or tagging can be used to clearly indicate the voltage of each circuit. In summary, the National Electrical Code permits the mixing of 120-volt and 277-volt lighting circuits from different panels within the same low-voltage relay panel, provided that the circuits are physically separated by a barrier and are clearly identified by different colors or other means. Adhering to these requirements ensures the safety of personnel and equipment and helps to prevent electrical hazards. It's always advisable to consult the latest edition of the National Electrical Code and to seek guidance from a qualified electrical inspector to ensure full compliance with all applicable regulations. The barrier requirement is crucial for safety. It physically isolates the high and low voltage circuits, preventing accidental contact. This can be achieved using various methods such as installing a partition within the panel or using insulated dividers to separate the wires. The choice of barrier material should be non-conductive to prevent any electrical conductivity between the circuits. Additionally, the barrier should be robust enough to withstand the physical stresses within the panel and maintain separation over time. The identification of circuits is equally important. It ensures that electricians and maintenance personnel can easily distinguish between the 120-volt and 277-volt circuits. Color coding is the most common method, with each voltage level assigned a specific color. For example, black might be used for 120-volt circuits while red is used for 277-volt circuits. Alternatively, labels can be used to clearly mark each circuit with its voltage. The identification should be durable and easy to read even in low light conditions. Regular inspections and maintenance are essential to ensure that the barrier and identification systems remain effective over time. The barrier should be checked for any signs of damage or deterioration and repaired or replaced as needed. The color coding or label should be inspected to ensure that they are still clear and legible. Any changes or modifications to the electrical system should be documented and the identification system updated accordingly. It is also important to consider the overall design and layout of the relay panel. The panel should be spacious enough to accommodate all the circuits and components without overcrowding. The wiring should be neat and organized, with adequate support and strain relief. The panel should be properly grounded to provide a safe path for fault currents. The panel should be installed in a location that is accessible for maintenance and protected from environmental factors such as moisture and dust. Furthermore, it is important to ensure that all the components used in the relay panel are rated for the appropriate voltage and current levels. The relays, switches, and other devices should be selected based on the specific requirements of the lighting circuits. All the wiring should be properly sized and insulated to prevent overheating and short circuits. The panel should be equipped with appropriate overcurrent protection devices such as fuses or circuit breakers to protect the circuits from damage in the event of a fault. In addition to the National Electrical Code, there may be other local or regional codes and regulations that apply to electrical installations. It is important to consult with the local authorities to ensure compliance with all applicable requirements. Local codes may have more stringent requirements than the NEC in some cases. The authority having jurisdiction typically does electrical inspections and can offer assistance in interpreting codes. It is always recommended to consult with a qualified electrical engineer or contractor to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. A professional can provide valuable expertise and guidance and help to avoid costly mistakes or safety hazards. They can also assist with obtaining the necessary permits and approvals. In conclusion, mixing 120-volt and 277-volt circuits in a low-voltage relay panel is permissible under the National Electrical Code, provided that certain conditions are met. These conditions include physical separation of the circuits by a barrier and clear identification of the circuits by different colors or other means. Adhering to these requirements ensures the safety of personnel and equipment and helps to prevent electrical hazards. Regular inspections and maintenance are essential to ensure that the system remains effective over time. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and standards. Remember, safety should always be the top priority when working with the electrical systems. In addition to the barrier and identification requirements, it is important to consider the ampacity of the conductors used in the 120-volt and 277-volt circuits. The conductors must be sized appropriately to carry the maximum current that the circuits are expected to draw. The ampacity of the conductors is determined by the size of the wire, the type of insulation, and the ambient temperature. NEC Table 310.15 provides guidance on determining the ampacity of conductors. It is important to direct the ampacity of the conductors if they are installed in conduit or cable trays with other conductors. Directing factors are provided in NEC Section 310.15. 8.3. The overcurrent protection devices such as fuses or circuit breakers must be sized to protect the conductors from overload. The overcurrent protection devices should be rated no higher than the ampacity of the conductors. It is also important to consider the voltage drop in the 120-volt and 277-volt circuits. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 210.19 provides guidance on voltage drop. It is recommended that the voltage drop in branch circuits should not exceed 3% and the voltage drop in feeders should not exceed 5%. Voltage drop can be minimized by using larger conductors or by reducing the length of the circuit. The grounding system is also an important consideration. The grounding system provides a lower impedance path for fault currents to return to the source. This helps to protect personnel from electric shock and to prevent equipment damage. The grounding system must be installed in accordance with NEC Article 250. It is important to ensure that all metal enclosures and equipment are properly grounded. The grounding conductor must be sized appropriately to carry the maximum fault current. Surge protection is another important consideration, especially for sensitive electronic equipment. Surge protection devices can help to protect equipment from damage caused by voltage surges or spikes. Surge protection devices should be installed at the service entrance and at any sensitive equipment. The type of surge protection device should be selected based on the specific requirements of the equipment. It is also important to consider the environment in which the relay panel is installed. If the panel is installed in a damp or corrosive environment, it may be necessary to use special enclosures or materials to protect the components from damage. The enclosure should be rated for the appropriate environmental conditions. It is also important to consider the ventilation of the relay panel. The panel should be adequately ventilated to prevent overheating. The ventilation opening should be protected from dirt and debris. In addition to the technical requirements, it is also important to consider the safety aspects of working with electrical systems. Only qualified and trained personnel should be allowed to work on electrical systems. Always to energize the circuit before working on it. Use appropriate personal protective equipment such as gloves and safety glasses. Follow all safety procedures and precautions. If you are not comfortable working with electrical systems, contact a qualified electrician. Electrical work can be dangerous and should only be performed by those who are properly trained and equipped. Before working on any electrical system, it is essential to verify that the power is off. Use a voltage tester to confirm that the circuit is energized. Always treat electrical circuits with respect and assume that they are alive until proven otherwise. Working safely with electricity requires knowledge, skill, and attention to detail. Never take shortcuts or compromise safety for the sake of speed or convenience. It is also essential to maintain accurate records of all electrical work that is performed. These records should include details about the circuit's components and wiring. Accurate records can be helpful for troubleshooting problems and for making future modifications to the electrical system. The documentation should be kept in a safe and accessible location. In conclusion, mixing 120 volt and 277 volt circuits in a low voltage relay panel is permissible under the National Electrical Code, provided that certain conditions are met. These conditions include physical separation of the circuits by a barrier and clear identification of the circuits by different colors or other means. In addition, it is important to consider the ampacity of the conductors, the overcurrent protection devices, the voltage drop, the grounding system, surge protection, the environment, and ventilation. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and standards. Remember that safety should always be the top priority when working with electrical systems.